let's do this question 8. I think it's zoomed properly now. Hope you can see wherever you are. So the statement reads as follows: after flying a short distance, an insect came to rest on a wall. Okay, so this is question 8. The statement reads as follows: after flying a short distance, an insect came to rest on a wall. Thereafter, the insect started crawling on the wall. The part that the insect crawled can be described by this equation, where h is measured in centimeters. It's the height above the floor, and t is time, which is measured in minutes since the insect started crawling. So 8.1 says that at what height above the floor did the insect start crawling? So it started crawling. So you think of it in terms of a Cartesian plane, where you have your height here and you have your time there, right? When you talk about it starting to crawl, it's where t is equals to 0, right? It started crawling at a certain height, right? But you don't know that height. So, but we know that t is equals to 0 at that height, at that specific height, because the movement can be, if you look at this equation, it is actually cubic, so it can be in cubic form like this, right? So just to answer this question, it started crawling at t is equals to 0, so meaning you're gonna substitute h of 0 here in this equation that you're given. Just gonna put 0 where there's t, so it's 0 minus 6 and minus 2 into 0 squared plus 3 into 0 minus 6, right? I hope everything is clear, but to write it nicely, I'm going to do it here. So t equals to 0, which is h of 0 is equals to 0 minus 6 and minus 2 into 0 squared plus 3 into 0 minus 6. So this will be 0, this will be 0 and 0, so it's going to be h of 0 is equals to minus 6 and minus 6, which will give you 32. So this is 32 centimeters. So this is basically your y-intercept, right, when x is 0. It's just that, you know, when you read these things in real life, you know, some students ask, but where do we use maths in real life? So this is the one of the examples of real life situations for maths. So yes, we found our h to be 32 centimeters. Now let's do 8.2. How many times did the insect reach the floor? You see, so if we don't picture how we've been calculating things over the years or over months or whatever, then we won't be able to answer this question. It asking us how many times did it reach the floor. Picture the floor as a Cartesian plane again. As I said, this is h, this is t, right? And this thing touched the floor. So whenever it touched the floor, so think of it as, oh, these are x intercepts, right? When y is 0, right? When the height is 0, because the floor, there's no height. You are standing on the floor, there's no height, so it's 0, you know. So when it touched the floor, the height was 0, right? So how many times did the insect touch the floor, reach the floor? So we want to identify how many x intercepts, which in this case, those x intercepts are your times t, right? So please note that. So we just want to know how many times it touched the floor. So we're just going to use our equation of h of t is equals to t minus 6 and minus 2t squared plus 3t minus 6. Actually, let me write it in another page so that you can see clearly. So h of t is equals to, let me just see. So it's t minus 6 t minus 6 and what? Minus 2t squared plus 3t minus 6. Minus 2t squared plus 3t minus 6. Okay, so we want to know how many times it touched the floor, and when it touched the floor, we know very well that h of t was equal to 0. The height was 0, right? So we're going to say t minus 6 and minus 2t squared plus 3t minus 6 equals to 0. T is equal to 6, that's the first one, or minus 2t squared plus 3t minus 6 equals to 0, right? And then you can find t for this problem here, which I did that previously earlier on, and I found that you can use your quadratic formula here, or you can factorize if it's possible to factorize. So I found that this was actually no solution, because it was giving you a negative square root. So in the square root you're getting a negative number, right, which is just an error. So the graph, the insert touched the floor once at t is equals to 6. So we can just confirm, because they said how many times does it touch the floor. It touches the floor once, right, at t is equals to 6. So that is your answer, because if you just write this answer here, you're just going to get 1 mark and you won't get full marks, you see. So you need to answer the question. Yes, you answer the question in calculation form and also conclude with just word form. So we are done with this question. So now we're going to do the last part of the question, which is 8.3. says determine the maximum height that the insert reached above the floor. Maximum height that the insert reached above the floor. I said initially, if you remember clearly, that this equation is actually a cubic function. If you check, the first part is a quadratic, the second part is linear. So when you multiply both, you get a cubic function. So want to determine the maximum height that the insert reached above the floor, sorry. The maximum height that the insert reached above the floor. So we know that our h of x is equals to t minus 6 and minus 2 t squared plus 3t minus 6, right? Let me just first find the product and then I'll explain everything else. So h of t is equals to, so I'm going to multiply through this t in each and every value here, and also 6 in each and every value there. We all know how to find the product. If you don't know, please ask me in the comment section below, but I'm just doing it as we speak. So it's going to be this t multiplied by this minus 2t squared, which will get minus 2t squared, t cubed, sorry, minus 2t cubed, and then this t multiplied by 3t, so it's going to be plus 3t squared, and then t multiplied by minus 6, so it's going to be minus 6t, and then minus 6 minus multiplied by minus 2t squared, it's going to be plus 12t squared, and then this same minus 6 multiplied by 3t, it's going to be minus 18t, and then minus 6 times minus 6 is plus 36. Collect like terms, you have h of t being equals to minus 2t cubed, and then you add these two here, you get plus 15t squared, and then these ones here you have minus 24t plus 36. So this is your h of t. Once you identify the maximum height above the floor, right? So yes, I guess the question says that the maximum height reached by the insert above the floor. As I said, for you to understand what's happening, think of it in a graph format. In this case, this is a cubic function, and this cubic function is an a value which is less than 0, right? So which means if it's less than 0, if you were to just write the movement of this, it's going to be, oh sorry, it's going to decrease, increase, decrease, right? I'm sorry with the background noise, it's beyond my control. So it's going to decrease, increase, decrease. This happens when your a value is less than 0, but when your a value is greater than 0, your cubic function increases, decreases, increases. I hope you know this. I'm just doing a mini small revision with you guys. So that is that. So in this case, our a value is less than 0, meaning that our function is decreasing, increasing, decreasing, right? You'll see why I just drew that. So now what we want to do is this. We're having our cubic function there and we want to find the maximum height. So the first thing we need to do is we need to derive this. So we're having h of t is equals to minus 2t cubed plus 15t. Actually, let me write with a black pen. I think it's clearer. H of t is equals to minus 2t cubed plus 15t squared minus 24t plus 36. So to derive this h of t, the derivative is minus 6t squared plus 30t minus 24, right? Then we equate this to 0, and then we get minus 6t squared plus 30t minus 24 equals to 0. Divide by minus 6 all sides. We're going to get t squared minus 5t plus 4 equals to 0. Factorize this t and t, 4 and 1, negative and negative equals to 0. T is equals to 1 or t is equals to 4. So we have t is equals to 1 and t is equals to 4. So I'm not going to present a Cartesian plane, but in just general sense, t is equals to 1 and t is equals to 4. T is equals to 1 would be somewhere here. T is equals to 4, sorry, would be somewhere here, and then t is equals to 1 would be somewhere here. T is equals to 1 would be somewhere here, right? So you can see now that the point of maximum is actually here, right? And not t is equals to 1. So we can only consider t is equals to 4 because this is the point of maximum for this function here. So what you're going to do is this. This is not equals to this, but it's equals to that. So when I say t is equals to 4, now I want to identify the height at t is equals to 4. So we use our equation. H of t is equals to what's the h of t is equals to minus 2t cubed, right? And plus 3t, no, sorry, not plus 3, plus 15 plus 15t squared minus 24t plus 36. So let's substitute when t is equals to 4 because that's when this insect reaches maximum. So it's minus 2 into 4 to the power of 3 plus 15 into 4 to the power of 2 minus 24 into 4 and then plus 36. So the maximum height that you need to get, just punch this into your calculator, you should get 52 centimeters. Remember, the height is measured in centimeters, so height at t is equals to 4 is 52 centimeters, right? So yeah, we are done with this question here. Off to the next one. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.